Alrighty, today is the last bit of our differential equations today, and what it is called is a direction or a slope field. So slope or direction field for a DE. Is what it's termed. So if you look at, say for example, let's consider the differential equation where we have dy dx equals 2x minus 2, for example. So what we know about this, because dy dx, of course, tells us about the gradient. So what we know about this particular thing is we can work out the gradient at any time. So for example, when we know that when x is equal to 3, so when x is equal to 3, the gradient of the curve that this relates to so the gradient of the curve is 2 times 3 minus 2. So we know that the gradient is 4. So we know the slope of the graph that relates to it. We know it has a gradient of 4, so we know it's going to be reasonably steep at x equals 3. What we also know is that if we anti-differentiate the 2x minus 2, we know that that would be x squared minus 2x plus some constant. And so here's the thing we don't know, and we haven't got any information to tell us about that. So we know this is going to be parabola shape, but the question is whereabouts is this parabola going to be? Because we don't have information to work out what this constant is, we don't know precisely where the parabola is going to be, but we do know some stuff about it. We do know that when x is equal to 3, the gradient of it is going to be 4. So what we know is if we graph this, what we know is this. What we know about our curve is that when x is equal to 3, it has a gradient of 4, so here's x equals 3, it has a gradient of 4, but what we don't know, so we know it's quite steep here, but what we don't know is exactly where it goes. So if we have a look at some other values of x, for example, and again using this dy dx, so dy dx, which is our gradient, 2x minus 2. If we look, say, when x is equal to 2, then our gradient would be 2 times 2 minus 2, which of course is 2. So here, at x equals 2, the gradient's a bit less than that, what it was there. And then if I went to x equals 1, the gradient would be 2 times 1 minus 2, which is 2 minus 2, which is 0. And so it would have a gradient of 0, so it would be flat there. And then we could, again, put x equals 0. And so the gradient would be 2 times 0 minus 2, so it would be negative 2. So we know here the gradient's there. But what we don't know is, when I've drawn it so that it looks like it's curving around there at that place, but because we don't know this constant, we don't know whether it's there or whether it's down here a bit. Or whether it's down here a bit. Or whether it's up here. So now I've put all these funky lines that represent gradients at certain x values that are above each other. And these lines here that I've drawn with all of this is what's called the slope or direction field. So the lines at the x values are telling you what the gradient is for that particular x value. Alright, so there's lots of them you can stick in. Keep sticking them in. You end up with all of this, right? With all of these lines. So what you've got to do is you've got to kind of visualise what's going on with it. So direction, slope, field, you kind of go, oh, what's going on here? Okay, so over here it's coming down, it's getting flat here, and then it's going back up. Like a parabola. But again, because we don't know the C, we don't know whether the parabola's there or whether it's down here or anywhere else. Alright. So these things can, because of all these lines that are on there, these marks that are on there, they can be quite confusing when you look at them. But kind of remember, they're the gradient, and what's happening with the gradient which is going. So, you know, if you think, sometimes they call it direction, sometimes you might see with little arrows on them. And then you can kind of follow those arrows, which way the arrows are going. As you come down, the arrows are pointing at where they're pointing at. So over here, the arrow's pointing me that way, but then when I get to the next one, it's pointing sideways. So I go sideways, then when I get to the next one, it's pointing me to go up that way, and then when I get to the next one, it's pointing me to go. So you're following the arrows around when you go left to right. Alright, so as I said, this is the slope or direction field. Right, so is there anything you want to ask me about that before we look at how our calculator...
The red line, sorry, can you just explain that?
So the red line is just like if I follow the way these directions are telling me to go. So over here it's telling me to go down there, but in the mid here it's telling me to go that way, here it's telling me to go that way. So if I follow, as I come down, it said go this way, go this way, go this way, go this way, I end up.
And you just put it wherever, like the red line wherever.
We would need to know some sort of initial conditions to know whether it's here or whether it's down here or anywhere else it's not. But we do know that it's there. It's not over here. It's not over here. It's here somewhere. Yeah, and we would need to know C to know precisely where it is. And then we would be given some initial conditions. Right, anything else? All right, so not uncommon to get a multiple choice question where you're given a direction field and then asked to make a selection about it for about something to do with it. If you need to draw one, your calculator can do that for you. So let's have a look at how that. Alright, so sketch. Slope field.
Okay, sorry, seems like you probably should
For the differential equation, dy dx equals y. All right. So our calculator. All right. So of course it's the Casio calculator for those in YouTube land. So you go to your menu on your calculator. So the menu on your calculator is a screen, and you'll notice there's a whole bunch of stuff. And you'll notice this one down the bottom here is called Diff EQ Graph. So then we go Diff EQ Graph. So when we do that, click on that, this is what comes up. Make this bigger. No, that's not what I want. Fixed size mode. Zoom, that's what I want. All right, so here we go. Excuse me. So here's our screen that comes up. Diff EQ, so the differential equation, what is it? So you'll notice here we've already got y dashed written in there for you, so you don't need to do the dy dx equals. So just like the graphs and tables where it's already got the y equals in there. So all we need to do is put, well, what is y dashed equal to? In this case it's equal to y. So y dashed, and we just put y in there, which of course we get from our keypad. There it is. And then the one up here, see, it looks like it's got all that direction fieldy thing in there. And so we tap on that, and then it draws it for us. So you can see on your class paddy thing here. Look at that, let's go to extra large. You can see in the class pad here, see how it's got arrowheads on it. So, you know, where does this arrow tells me to go here, and then when I get to there, what does it say? It says head that way, head that way. So this is kind of curving around like so. Over here, what's it saying to do? Same thing over here, curving around like that. Over here, what's going on? Yeah? And so then if you need to, draw a sketch. And so all the ones across here pointing this way. Above the x-axis pointing this way. And the lower we go down, the steeper it becomes. And similar kind of thing here. Alright, so if we were to look at that, we'd say, alright, well this is swinging around like this, some way or other. If we had to kind of think how it was swinging. And again, we don't know whether it's there or whether it's over here or something. We would need to know some more information. Alright, anything about that? Yes, no, maybe? No. Got another example. And then we're done with the theory for today. Alright, am I right to rub that off? Yes, no, maybe? No one's saying anything, so I'll rub it off. Alright, so last example, again using the calculator. So this one in G, use the CAS. Alright, so differential equation this time is negative x on 2y. And this time we're given some information. So this time we're given the initial conditions. And our initial conditions are x equals 0 and y equals when x equals 0, y equals 1. Alright, so you do the same process as you did before on your calculator. Alright, so you go to your menu, go to the differential equation graph tab, application I should say. Then on the differential equation tab you enter the differential equation, that's this one here, so the negative x on 2y. Use the template in the keyboard for that. Alright, so negative x over 2y. Alright, so that gets entered in there. Now, you'll notice there's 3 tabs up there. There's the Diff EQ tab, which is where you put this stuff. So the Diff EQ tab. Where that stuff goes. But you'll notice there's other tabs there. One says IC and the other one's graph. The IC tab is where we put this information, IC or initial conditions. So if you go on that, IC, and there you can see that's got an X and a Y value that you can put in. Alright, so you don't need to do x equals, y equals, it's already done. So all we need to know is that x is 0, and when x is 0, y is 1. Initial condition 2, so there's more if you want to put more in. Notice there's a checkbox, make sure you check the checkbox, otherwise it's not going to put in the initial conditions in its calculation. And so when we do that, tap graph on the graph icon, we tap that, there it is. Alright, so here we are. Here's the slope or direction field. All those green lines there. So they start here and swirl around, they start here and swirl around. But because we've got initial conditions, x equals 0, y equals 1, x equals 0, y equals 1 is where that pink dot is. So the particular graph that we're looking for is the one that curves around through that pink dot. Alright. Anything about that? No. Alright. So yeah, with all these arrows on here, it can sometimes get confusing, so just, you know, you're kind of looking at what directions it's pointing you to go. Alright, so you just follow that direction. Alright, so sometimes it's called the slope field, the slope meaning the gradient, and then the direction, you know, if you're moving along it, which direction are you going? So it's kind of interchangeable, depending on how you want to view it. Alright, that's it.
Oh, I was going to ask a question. Like, say you got this in an exam.
Yep.
Do you draw the arrowheads or just the distance?
It's probably not totally necessary to draw the arrowheads if you have to draw it in the exam. I don't think they'd be that fussy. But the more common question in the exam has been a multiple choice.
Ah, okay.
I'll find one to show you. Alrighty.